Hello everyone, this is the video lecture for pre-calculus. We're doing 7.5 complex numbers and de Moivre's theorem, or de Moivre, I don't know. De Moivre, that's what I was told. I'm not French, so I don't know. What's going on here? Well, last time we were doing polar, but now we're doing complex polar-ish stuff. So here, last time we were doing x and y goes to r and theta. Not last time, but the time before that. But anyways, cool. Well, what we're going to do this time is a plus bi. It will also go to r times cosine of theta plus I times sine of theta. Okay, so this is still rectangular, and this is definitely polar, but now we have the complex forms of it. So a plus bi, it's basically saying x plus yi. So that's just another way to write it. It literally is just another way to write it. It's not like you actually have to do a lot of math. You don't have to make it too complex. It is just what it is. So I'm just going to make it clear for you, okay? Let's just say that we had a point at 2, 3. 1, 2, 1, 2, 3. There you go. Now, let's say I had 2 plus 3i. Let's graph that. Are you ready? 1, 2, 1, 2, 3. Hey, that looks the same. Yes, it is. Okay, that's a smiley face, by the way. Yay. So what about this guy? So r theta and same kind of business here. Now, there's an easier way to do this, much easier. It's called RCIS theta. And the CIS is not what my math lab will teach you. This is just Chad, but it's so much better. So RCIS theta. But notice that you had to write all these thetas and stuff, and all these other things going on in parentheses. It just comes down to this guy. Let's make an example. Let's say that I had a point. Let's just make a point. Let's say I've got 3 comma pi over 4. Okay, so we're going up at pi over 4, and we're going to go 3 distance. 1, 2, 3. There it is. But now let's do 3 CIS of pi over 4. Guess what? Same thing. 45 degrees. 1, 2, 3. Yay! It's the same thing. Okay. I will be using the CIS format often. And I got special formulas that use the CIS method, I guess you can say. The format, really. So I'll be using this extensively. But my math lab does not want you to do that. No, no, no. Instead, my math lab wants you to do it the long way. And what is the long way is the r cosine of theta plus I times sine of theta. The long way is the long way. And that's fine. It's correct, but this is also correct. Okay? Glad we established that now. Okay, well, let's do some problems. So this is going to be a bigger section. So kind of just hang out with me. Here we go. I've got 6. I just wish my stylus was just so much better. This is not as quick as I want it. So 6 plus 7i. This is it's called the real component. And like, you'll never have to do this again, but whatever. And all this stuff here is called the imaginary component. I'm trying to be a good teacher and give you like the actual names and definitions and stuff. Okay. Yeah. But like I had said, all this here is just x plus yi or iy or whatever you want to call it. So that's your x and that's your y. Here we go. So I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Ta-da! They might use not X and Y. They might say this is real and imaginary. And I mean, this is so much cool stuff going on. I had a full graduate class just on complex variables like this. A whole entire class devoted to this topic right here in graduate school. So it's really fun. And I really like it. I think there's a lot of applications and stuff, but that is not the scope of this pre-calculus class. Right now we are introducing it and moving on, okay? So the next thing they're going to ask in this particular question is for this thing. And I just want to draw it before I give it any kind of verbal. They say, what is that? They might even use the word absolute value, though if they do, they're pushing it. I can't say that they're wrong, but I would definitely say that's not the way. That's not the right way of seeing this. It's not absolute value. Instead, what this is the magnitude. There's some other names here. The distance, the radius. That's a good one right there. Or the modulus. This is what the real pros use. Are you a professional math person? You say, oh man, that's the modulus. Anyways, what is it? Well, radius kind of gives it away. It's going to be the Pythagorean theorem. And there we go. So, blah, blah, blah. Square root 85, I don't think it reduces. So, ta-da! There's your part B. Super easy stuff here. It really is. Let's do some more of this stuff without having to like go super in-depth analysis every single time. So I got -8 plus 6i. Whew, man. I wish this stylus would just keep up with me, man. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Yay! We did it. Hey, what's the modulus of this thing? Well, you do some Pythagorean theorem. Notice that I did not include a negative sign with that 8. Because I know that it's going to cancel anyways. So don't make a big deal about it, okay? When you get to Calculus 3 and I start doing this stuff, just, it's normal, okay? It's totally normal. Okay, cool. Now, so like, what is this 10? 10 is a little bit easier to see. 10 is the distance from here to there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ta-da! It worked! Man, I'm so good at graphing. Okay. 16 minus 16i. Do it again! I guess. 1, 2, 3, 4, 16. 1, 2, 3, 16. Well, negative 16. Wow. That was so fun. And hey, oh. Okay, there we go. It's just that, like, I actually have to write this stuff? Come on. 16 square root 2. Just to kind of cut to the chase scene here. Yeah. No big deal. Moving on. Okay. 3 square root of 3. plus 3I square root of 2. And then it says convert to polar. Like complex polar is kind of what they're saying. First off, I want to know what this picture looks like. So 3 square root of 3, 3 square root of 2. Again, that I is just kind of there because it's easier to see right here rather than putting it right there. You'd have to kind of drop this down, and some people get confused. So they just kind of, say it's 3 square root of 2. You put an I wherever you want, kind of thing. Well, it looks like it's somewhere here in quadrant 1. I don't know exactly where. There you go. Point B. But the question's asking for blank plus cosine of blank degrees plus I times the sine of blank degrees. And go. Figure it out. This is an R. This is a theta. This is a theta. Well, how do you find R? Oh, I don't know. Probably the square root of the squares. That sounds like a good idea, right? Right? And so I got 9 times 3 plus 9 times 2. 9 times 5? Oh, yeah. 3 square root of 5. There you go. Okay. What about my theta? Well, it's in quadrant 1, so therefore my arctangent should just give it to me. So arctangent of 3 square root of 2 divided by 3 square root of 3. They cancel. What happens is this is 39.2315 degrees. Whatever they want, round to whatever decimal places. You know what my math is probably going to do? Just a guess. They'll say, find the exact value of this, but not this one. Just go ahead and round to like 1 decimal place. Grrr. Anyways, so you put this 3 square root 5 here, and you put the 39.2 and the 39.2 right here. So it's so nice that they gave us boxes to fill in. No confusion at all, man. No way. These problems are really not difficult. If they seem difficult, then I think that maybe you're overthinking it, because it's very systematic. I'd almost say it's boring. Okay. So, it says convert to rectangular, whatever. Anyways, so we have an R, and we have our theta, and they want x's and y's and stuff like that. So R cosine of theta is equal to 8 cosine 2 pi over 3. Cosine of 2 pi over 3, that's 120 degrees, I believe. So my cosine would be a negative 1/2. Therefore, we get a negative 4. I'm not going to box it in. We're not quite there yet. Y is equal to R sine theta. Same thing, except that right here we get a positive square root 3 over 2. So 4 square root of 3. All right, now we need to convert this. We need to write this in the proper format. So this is the point, like the xy point that they're talking about, but they're wanting to put it into complex form. So negative 4 plus 4 square root of 3, close, and then an I. You can also put the I somewhere else, but as long as it's somewhere with those other numbers, it's fine. There you go. We did it. Man, feels so accomplished, huh? Okay, so 7, 5, 39. I got z is equal to 2 times cosine of pi over 11. Man, CIS would be so much cleaner here. I mean, I just don't know why nobody uses it. WebAssign doesn't use it either, by the way. The other program you'll be using in calculus, they don't use CIS either. And it's just a thorn in my side, man. Like it's so easy to see and to write, and the formulas I'm going to be giving you make it so much easier to do the CIS, but just we have to get there, okay? We have to get there. All right, so formula time, kind of. They're saying find z times w, and they have a box, and then they just got to make it so long. I'm sorry. It's dreadfully difficult, man. Okay. Gosh, okay, let's just pause for a second. Because I'm like writing constantly when I've already got the answer. I already got the answer in my head. It's not a big deal, guys. It's such an easy thing. But I have to write it all out. You have to type it all out. Whew. All right, here we go. So, time for a formula. Z1 times Z2 is equal to, and here's the fun stuff, R1 times R2 times CIS of theta 1 plus theta 2. There it is. There's your formula. It's so nice, isn't it? Oh, my math lab wouldn't stand for something so nice and clean as that. There's no way they would let you go and get all happy about some kind of math formula that's not in their particular format. No way. Leave it to my math lab to always want the elongated version. Oh, man, so picky. There you go. Man, that's twice the length. 3 times the time, man. My hand hurts. Okay, so let's actually talk about what's going on here because I'm just griping. I'm sorry. I need to stop griping. Right in the middle of a video, I need to be professional, right? So, when you're multiplying on the outside, you're adding on the inside. But you're also multiplying on the outside still, aren't you? Look at that. Do you see that? Multiply, multiply. What are you doing? You're multiplying? So go ahead and keep multiplying. Oh, but wait, on the inside, now you're going to be putting a plus. And I'm trying to emphasize that you can see the symbols, right? And so if you just take this one and like, just twist it a little bit, and then you got the same symbol, don't you? That's just what I do to kind of remember that stuff myself. So there's just one of your formulas, and it's so easy to do. All right, now let's go back up here. I'm supposed to multiply these two things together, okay? So it's 2 CIS pi over 11. I also have 4 CIS of pi over 12. So when I'm multiplying them together, I've got 2 times 4 times the CIS of pi over 11 plus pi over 12. There it is. There's our answer. We're done. Let's go and simplify it. Okay. So you know what? I'm going to go this way with it this time. And so what we do is I'm going to say, well, this one's 8 in the front. That's pretty obvious, I guess. And then I need to add these guys. Now, common denominator, blah, blah, blah. Use the calculator. And by calculator, I mean scientific calculator, of course. And this is what I got. You don't need to put the pi's. If you're putting the pi's in there, you're doing it wrong. Don't do that, please. Okay, there's your answer. I mean, look, that was all we had to do. There it is. Right here. You're looking right at it right here. Wham. There it is. It's not hard. Not. Okay, so then let me start griping again, huh, Chad? Because it can't be that easy. Thankfully, my math lab just has the boxes. So you're just like filling it in twice. It's not really a load off your back. It's not. Is that an expression? I don't know. It's not that big of a deal for you. I understand. But later it will be. So let's do another one. This is a great spot. 7,541. So I've got Z1 is equal to, and you know, it's okay. It's okay, Chad. You're going to get through this. You're going to get through this, and it's going to be wonderful. Oh, man. Look at what we have to do. Okay, it's fine. It's fine. Okay, there we go. Gosh. So, Z1 times Z2. What is the answer? I mean, okay. What is the number on the front? Tell me, what is my R? Right? If I need to convert these over to RCIS formats, right? R is what? Oh, I know you know the theta. Don't worry about that. Everyone knows the theta. So that one's an easy one. What's my R? You ready? 1. Yeah, it's 1. Of course, there's a 1 right here, and a 1 right there, and a 1 right there, and a 1 right there. You can factor out a 1. Da 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 da. Okay, so we got 1. So then when I'm multiplying, I got 1 times the CIS of 2 pi over 3 plus pi over 6. And you're done. I do this in the calculator, again, without the pi's. And then I put the pi back in. There's your answer. Oh, no. There's no way my math lab would take... Nope, wrong. There's no way that that's a good answer. Who taught you that stuff? No way. Who said math was that easy? Ugh. So they want you to write it out this time. So start appreciating the CIS format, okay? I have a whole other thing that I did. I was actually like finding the real values of X and Y, and my math lab doesn't want it for this problem. So I went too far. But I'm just tired of writing, so I'm not going to show you that. I was planning on like saying, oops, I did it wrong, I need to go back, but I just don't care anymore. All right, let's keep going then. I got Z1 is equal to 5 plus 5i. I've got Z2 is equal to negative 1 plus I. And they say find Z1 times Z2. All right, finally a challenge. Finally something that we can do. Oh, man. Okay, now this is actually fun because it's not so boring. There's 2 ways to get this answer. I'm going to do it the manual method. Okay? So, I'm going to just call this the, I'm just saying it manually, I guess, okay? What do I mean by that? It says to multiply these 2 things, right? And I'm going to do that. I'm going to multiply these 2 things together. I'm going to FOIL them. Yeah. 5 times negative 1 is negative 5. 5 times the I is a 5i. 5i times negative 1 is a negative 5i. And then I got 5i times I is a positive 5i squared. Okay, Now, it just so happens that these guys cancel. That's kind of a rare thing. Normally, you're definitely going to have something left over, but here we don't. If you remember, there's a formula for I squared. I'm trying to get rid of that 5 there a little bit. Okay, there we go. There's a formula for I squared. I squared is equal to -1. And so you can just write a -1 there. So I got -5 and another -5 makes a -10. And that is literally your answer. Oh man. No. Where is -10? It's like way down here, right? -10. Well, then what's my angle? Well, it's 270 degrees, I guess, or 3 pi over 2. Okay. How much distance did you travel down? Well, I guess it was a 10 distance. Very good, very good, very good. Yeah, that's right. So now, I don't have enough room for this. Man, they're wanting the long way. 10 open cosine of 3 pi over 2. Oh. Whoa. Back up. Back up. Right here. Whoa. Back up. I was being too silly and I thought too much. -10. Well, I thought -10 was my y value. That is totally wrong. It's definitely not this at all. Remember one thing. Here, just chill out for a second. See, I thought, oh, you got like a y value, right? Because that's just what you get out of these things. No. That's actually an x value. Why, though? What's going on with this? Let's pause for a second. What you actually have is 10 plus 0i, x plus yi. So, what is your y value? It's not -10. It's 0. What you're actually looking at is -10 out here. And so your angle's different. It's now going to be a pi angle. And then you travel a 10 distance. So 10 cosine pi plus I times sine of pi. That's what they want. Now, I don't like the manual method because it's great for like small problems like this, but not good whenever you got something much bigger. So what I want to do is I want to do it properly. I didn't do it properly? I didn't do it at all. That's interesting. Well, that's where my notes stop. Let's do it the proper way. And you won't have a problem with this -10 business happening like I had. See, I made a mistake because I was doing it the manual method, which is totally fine. But I think the proper method is going to be a little bit better. So hang on tight with me, okay? So I've got, again, 5 plus 5i, and let's try to make that a little bit better. And I have -1 plus I. So on the graph, this is over here at 5, 5, okay? And so you can see what's going on. This is a 45-degree angle. And I'm actually going a distance of 5 square root 2, okay? This one is kind of similar. I got -1 for x, +1 for y, so this is 1 and 1. It's right there. So my angle is not 45 anymore. This is 3 pi over 4. And the distance is square root 2, okay? So what I actually have is 5 square root 2 CIS pi over 4. And then I'm multiplying it by square root 2 CIS 3 pi over 4. Okay? Now remember, when you're multiplying, the numbers are just simply multiplied. And so I got 5 square root of 2 times the square root of 2. And then the angles are added. Pi over 4, 3 pi over 4. And if you look around, these 2's actually combine together to make a 2, like a regular 2, and 2 times 5 is 10. And then when you add these together, you get a plain 1 pi. And there's your answer. I mean, rewrite it however my math lab wants it. But notice that I did not mess up. Because if you do it the proper way, then you don't ever have to worry about trying to interpret what you got. Okay? So that's the way I recommend it, actually. But I just wanted to be funny and show you that there are different ways of doing these problems. If they say you multiply something, go ahead and multiply something if you want to. That's fine. No one's stopping you. Okay. I'm going to just do some shorthand now because I'm thoroughly fed up with my math lab, and I'm just going to do CAS, and I don't care what they say, okay? I'm pretty sure that you can convert this into whatever format you need afterwards. Remember that I've been joking with y'all in class that this is 2412. The 2 right here means it's upper level, which means I can do that. It's just the 2 right there means I can skip steps. Anyways, here they're wanting Z1 divided by Z2. So let's do a formula for it. It's actually very simple. It's R1 over R2 CIS of theta 1 minus theta 2. So if you're dividing, you divide on the outside, like you should, but then on the inside, you're subtracting. So 2/3 CIS pi over 2 minus pi over 11. Okay, well, there you go. There's your answer. Of course, I'm going to put that into the calculator to simplify it down without the pi, obviously. And there's my answer there. So just to remind you that my math lab will be very upset with you if you tried the CIS format. I wonder if they take points away ever, Do you ever think that they'll do that? They're like, you know what? You learned it from Chad. Obviously, we're going to have to just take away all your points. No, I wouldn't have put him past him, though. There you go. Not too bad. So anyways, this is a formula. That's a formula. You can see the patterns at this point, right? Let's talk. So when you're multiplying on the outside, you continue to multiply on the inside, but on the outside. But on the inside is now plus. If you had a division, then there you go. Then it turns into subtract. Isn't this just a look at this symbol? I never noticed this. What is that? It's saying that there's something on top of something else, right? With the fraction, like there's blah blah blah, and then there's some blah blah blah. That's what that symbol means, I bet. Ooh, we just learned something fun. Anyways, this style is very important. Let's do one more. Oh man. Okay. I want to be cheesy on this problem, okay? How cheesy do you want me to be? You don't want me to be cheesy. Okay, fine. I won't be cheesy. If you're disappointed, then I'm sorry. They say to do this. Now, I did it manually on my paper, and it was just so funny. It's so easy to do, but I'm not going to do that. I want to convert to CIS and do it properly and all that stuff. Okay, so let's do this one. So Z1, notice that it's 4 and 4. So it's like up here, so 45 degrees, and my distance is 4 square root of 2. Okay. For this guy, it's actually similar. It's just going to be 2 square root of 2, and yet still at pi over 4. That's supposed to be a 4. So now I'm dividing both of these, and so just as you think, you should definitely have these divided. And then on the inside, you're now subtracting them. And so then the square root 2's cancel, and that's just a 2. These guys cancel, make a 0. I don't know. There you go. Yay. That is the answer, by the way. Okay, so looking ahead. I got 1, 2, 3, 4 more problems. 4 more problems, and then we're done. These are all very different, okay? So these are very different. If you were not paying attention because it was so boring, now's the time to start paying attention a tiny bit. So here's your first one. We got cosine of 20 degrees. I got an I times sine. I don't like what's going on here at all. It's okay. It's okay. Just be patient, Chad. Be patient. Okay. All to the third power. So all this stuff to the third power. I mean, what are they really saying? 2 CIS 20 all to the third power. So what that means is that it's multiply, multiply, multiply. Now you can go and do the multiply things if you like. But this is that de Moivre's theorem stuff. And it's super cool. So here's your de Moivre's theorem stuff. So R CIS theta all to the n power is equal to, well, R to the n, because it's kind of like you're distributing it, kind of, CIS of n times theta. Okay, that's your formula, and it's super awesome. What's going on is that, again, it's this, it changes when it's on the inside. So if I had multiply, now on the inside it's going to be a plus. If I had divide on the outside, now on the inside it's a minus. But what if I had power? What happens then is that it turns into a multiply. That's supposed to be a caret, by the way. I'm trying to say like power, caret. So powers go to multiply, go to plus signs. What about this? What's the opposite of power is roots. So roots are going to go into division. And that's going to be a big problem here coming up in just a second, okay? We definitely have to talk about that. Anyways, this problem could not be any easier now that we got this all figured out. It's very simple. It's 2 cubed CIS of 3 times 20 degrees. So 8 CIS of 60. That's your answer. I mean, what else do they want with you? Well, they want more. Yeah, they always want a little bit more. So we can write this out in their longer method, of course, which I think that's what they're going to want because I have it on my notes. This way was one of the answers. So that's fine. But they also want it in rectangular form, as in we need to find x and y. Well, it's very simple to find those because I have formulas for those. And these formulas I've now memorized because I use them so much. You too. Haven't you memorized these? Nod your head, yes. Just like the unit circle, man. I use that all the time. And you will too. All right, we got our x and y. So then 4 plus 4 square root of 3 close I. There's your rectangular answer. Whew. Okay. Well, the problem was not hard, right? Look, this was your big leap from here to here. Do you think you can do that? Do you think you can do that? I think you can do that. I think you can. I have confidence in you. Let's do it again. So it says square root of 3 close, CIS of 5 pi over 6, and now all to the 4th power. So now it's the square root of 3 to the 4th power CIS of 4 times pi over 6. What's going on here is that you got 4 square roots. And so it actually says 2 and 2 combined, 2 and 2 combined. You got 3 times 3 is going to be a 9. And you can verify with a calculator, of course. Here, one of the 2's will cancel, leaving a 2 in the top and a 3 in the bottom. And so the 2 in the top goes with the 5 to make it 10. And it leaves the 3 in the bottom. And yeah, that's it. Yay, we did it. I mean, it's not hard math. Not hard math. Of course, my math lab is going to want you to do it a little differently. So here we go. X is going to be a 9 cosine of 10 pi over 3, which I am using the calculator a little bit to kind of get a little bit of help, because that's not the first revolution. Why did I put a 3 down there? That should be a 2. Y sine. I mean, surely you also feel like, oh, this is just so long. Don't you feel that sometimes? Like, why is my homework so long? Why did Chad make it so long? Well, Chad did nothing, okay? Chad didn't do any of that. I have my own opinions about what homework is useful for, but I'm always told, and I do mildly agree, that it's important for practice. And of course you need to practice. But I am not getting into pedagogy arguments here. So, all right, cool. We did it. You did it. You did it. You did it. I just watched. That's supposed to be a 5. Okay, 2 last problems. W is equal to 16 cosine of 60 plus I times the sine of 60. And they say, what's the square root of W? Okay. Hold on for just a second here, okay? Hold on. And I'm back. Okay. Yeah, I know. I'm not really able to pause so well. Sorry about that. Anyways, so what's the square root of W? So what do they mean by this? Well, if you went back to what we were doing up here, right there, the roots, not just square root, it could be cube root or whatever, nth root, it's going to lead to a division eventually. So we need to have a formula for general nth root stuff, okay? So the nth root of z is equal to what? Okay, so here's your formula. Here we go. It's, well, the nth root of r times CIS of theta plus 2 pi k all over n. And as long as k is equal to 0, 1, 2, blah, 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 all the way to n minus 1. Now, this one is definitely the lengthier formula. It's a little different than the others, but do you notice this 2 pi k business? I mean, isn't that similar to what we've seen in, I don't know, past sections? So what you were doing was not purposeless. It actually came back up and it's now here. Something else you should notice is that we're going to get multiple answers. So, like, you're going to get a lot of different answers and different answers. So here, this is technically a 2. Square root, there's a 2 there. Cube root, there's a 3, right? So squared, there's a 2. So the 2 is going to say that we have 2 different answers. All right. And so I just want to remind you that this is a 16 CIS of 60, okay? So I'm just going to plug this thing in. Here we go. So the square root of W is going to be the square root of 16. CIS of 60 degrees plus, and we don't want to mix our pi's and all that stuff, so we're just going to do 360. 360 times K all over N, which is a 2. Again, that K is going to be either a 0 or a 1. Well, what's the square root of 16 is a 4. I'm going to distribute my denominator, so then I got 30 degrees. And I've got 180 now, K. And again, K is equal to 0, 1, 2, etc. So this is basically my answer. I now just need to split it up into 2 separate answers. When I got K equals 0, and when I got K equals 1. And so we got 4 CIS of 30 plus 0. And then I got 4 CIS of 30 plus 180. Okay. So 30 plus 0 is 30. And so, yay, we're done. And I know that they're not wanting the CIS format, but at this point you can convert that, okay? And then the next one is, what, 210? Is that what it is? Yeah. Yay. All right, there's your 2 answers. Put them in boxes. I believe that they have like separate boxes for them. I can't really remember exactly, but you do definitely have 2 answers. Okay, now I want to talk more about the physical understanding what's going on here, because I didn't do that with hardly any of the other ones, but this one in particular is really neat, okay? So I really like the multiply and divide, and I'm sorry, the multiply and the add and subtract. That all makes more sense, but this is actually really important physically. So I started with 16, okay? Let's just make a big circle here. Out at 16. So this is 16, this is 16. And I started at 60 degrees, I guess. 60 degrees here. Awesome. My answers are no longer at 16. They're at 4. So there's 4 and 4. And then I have a 30 degrees. And I also have a 210 degrees. Okay. I don't know about the radius so much being as important, but I do want you to note that we have 2 slices. 2 slices, okay? Because it had a square root, it was the square root of W. And again, that 2 is super important now. So what if you had a cube root? Let's just like prototype it here. We're going to actually have a cube root in the next problem. But let's just say I had a cube root. Well, I'm going to start right here, and then I'm going to have 3 equal slices. So here and here. So 1, 2, 3. What if I had the 4th root? I'm showing you physical stuff here. You start at a place, and then you have 4 different answers. 1, 2, 3, 4. So the main thing is that you always got to start in one place, and then you could just go tick, 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 and you can get equal amount of slices. Kind of like a pizza in a way, you know? So you're cutting it up into however many slices you need. That makes it so much faster. If you know what you're doing, you don't have to do this math anymore. You could just say, well, I'm starting at 30, and boom, 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 boom. And it's so easy in the end. Okay. Now, I know that you're not going to do but like 3 of these problems in your life right now, but later it is much more important because you're going to have this eventually in another class, not probably with me, but if you're engineering, I'm sure you'll see something like this eventually. If you're a mathematician, mathematics, pure mathematics, you'll definitely see it again. If you're computer science, yeah, you won't see this again. But maybe, I don't know. Depends on what kind of field of computer science you're going for. Biology, I don't know. Physics, yes. I'm just trying to name some stuff here. Okay, so we got the cube root of 8 CIS 210. And so what I need to do is say, well, that's the cube root of 8, and then the CIS of, and now this is where it's 210 over 3, 210 over 3, and then plus, and how much am I adding each time? Think about it for a second, right? Isn't it going to be 360k over 3, right? 360 over 3. Well, what's 360 over 3 is 120. And so what you're going to do is, what's the cube root of 8 is a 2. What you're going to do is you're going to start at 210 divided by 3 is 70. You'll start at 70, and you'll just keep adding 120 degrees each time, okay? So that's kind of your formula. You start at 70, which is somewhere right here, and you want 3 equal slices. So again, you're adding 120, so it might be like right here, and then like way down here. 1, 2, 3. Now, let's find out what those are actually going to be. And so I've got 70 plus 120 is 190. Sounds about right. And then I've got the 190, and I'm going to add 120 more to that to make 310. There's all your answers. I mean, I'm going to flip the page to make sure I'm not missing something here. But those are all your answers. So I've got 2 CIS 70. I've got 2 CIS of 190. And then I've got 2 CIS of 310. And there we go. There's your 3 answers. 3 answers, 3 slices, 3 third root. All right. Did it. We're done. Thank you very much. Have a great day.